Have you seen the Terminator, iRobot, or Ex Machina? Pop culture movies like these inaccurately predict how a world with fully sentient robots would unfold. In reality, the future of advanced intelligence did not end in the mass extinctions of humans, but rather a world where the limitations and imperfections of the human body are no longer hindrances. By unlocking the Pandora's box of knowledge that is the human brain, the world will truly be at humans' fingertips. The quest for achieving a futuristic world began in 2013. Here, the world's most accomplished scientists and engineers from around the world congregated to hold a summit where they proposed 14 different grand challenges. These grand challenges are opportunities in engineering which are both achievable and sustainable in an attempt to help humans and the planet thrive. Among this master list is the task of reverse engineering the brain. The first stepping stone toward unlocking the human brain is to crack how it computes as fast as it does. In a research study led by Dr. Marcus Diesman and Dr. Abigail Morrison, engineers were able to use the NEST software framework to build an artificial neural network of 2 billion nerve cells, connected by 10 trillion synapses in an attempt to recreate human brain activity. However, they were not able to simulate the brain's activity in real time. It took 40 minutes for the K supercomputer from Fujitsu to recreate just 1 second in biological brain processing time, while in turn consuming 1 petabyte of system memory. The key for computers to process faster while consuming less data is to mimic the energy efficiency of the human brain. According to an article by Mark Fischetti, senior editor of the Scientific American, the human brain operates on the equivalent amount of energy needed to dimly light a light bulb, whereas the K supercomputer harnesses the equivalent amount of power needed to run 10,000 houses in America. Despite the K's ability to compute 4 times faster than the brain and store 10 times as much information, it is still decades away from being able to truly replicate the human brain. One of the biggest obstacles of replicating the brain is cracking neural computation. In the research paper Power Consumption During Neuronal Computation, it was discovered that human brains have the ability to use both digital and analog signaling, whereas supercomputers only use digital. This means that the human brain uses neurons to fire signals at various levels of strength, compared to supercomputers which use Boolean gates that either on or off with no in-between. In addition, the human brain has up to 10,000 different types of neurons which are all performing different tasks, while supercomputers only have 2 or 3 different CPU architectures to perform calculations. The flexibility and diversity of neurons is what allows the brain to process information incredibly fast while expending minimal amounts of energy. Here at Penn State, research teams are working on various projects to use neuronal computation in an attempt to mimic the power of the brain. At the Laboratory for Perception, Action, and Cognition, students and professors are researching software that is able to use symmetry and other pattern recognition techniques to enhance visual systems. Similar techniques are being utilized in another Penn State project, Visual Cortex on Silicon, an NSF expedition in computing. This project hopes to develop technology that will approach and eventually exceed the capabilities of human vision systems, while creating the foundation for later generations of machine vision systems to not only record images, but also understand visual content. Specifically, this laboratory is working on designing systems to give sight to those who are visually impaired.
Found the Prego tomato sauce on your list.
Reverse engineering the brain is not just a goal for better smartphones or personal computers. Having a full understanding of the brain will lead to deeper insights about methods for testing biotechnological solutions to brain disorders, such as drugs or neural implants. While neurological disorders may someday be circumvented by technological innovations, advancements in this area also give way to practical applications, such as advanced speech recognition software and advanced intelligence programs to guide devices that can safely enter the body to perform medical diagnosis and treatments. More ambitious programs hope to create systems that can control artificial limbs. Reverse engineering the brain is a project that needs to be funded by governments and private industries around the world. It will not lead to the mass extinction of humans, but it might lead to a brighter future.